Let's rewind the clock. It's 2005. We are looking at a 6-inch wet gas pipeline, 5 miles long, downstream of a field booster compressor. It runs across undulating terrain. The gas contains 2.5% CO2. It's not dehydrated, meaning saturated gas enters the pipeline with a small amount of free water carryover. There's a monthly pigging program. Continuous corrosion inhibitor injection. Sounds like best practice, right? At first, it was. In 2005, the flow rate was 40 million standard cubic feet per day. At that velocity, all the free water moved with the gas, no settling, no stagnant zones, no problem. Stratified flow kept the internal walls wet, but the water traveled fast, about 30 minutes end to end. There was essentially no time for corrosive chemistry to take hold. Pigging didn't really do much, but no harm either. The internal corrosion hazard was very low. Now fast forward to 2010. Flow had declined to 20 million. Still respectable. But now, 2 spots, just 2, along the pipeline had enough inclination to allow some water to slow and begin accumulating. Thick water films formed in those low-velocity zones, covering about 10% of the pipeline cross-section. Still, overall residence time was just 1.5 hours. Inhibitor still reached everywhere. The water moved fast enough to allow film formation. The system held. Corrosion hazard still low. Mitigation still working. Then 2015. Gas rate dropped again, now 10 million per day. Multiple terrain dips created more zones of thick water film. Total water volume in the line. About 25 barrels. Residence time. 18 hours. Still, everything was within range. The inhibitor had time to work. Pigging helped keep residence times in check, preventing pockets of low pH. The system was working hard, but it was working. Mitigation was still aligned with the risk. But then came 2020. Flow dropped to 2 million standard cubic feet per day. Just 5% of the original gas rate. And that's when everything changed. The same terrain dips now became water traps. The water no longer moved quickly. It settled. It pooled. In some spots, 30 to 50% of the pipeline cross-section was filled with stagnant water. Across the 5-mile length, 250 barrels of water now sat inside the pipe. And the residence time? 45 days. At these low velocities, something else started to happen. The saturated gas, still full of water vapor, began condensing. Especially in the last mile of pipeline, where temperature and pressure dropped just enough to cause rapid condensation. And this condensed water. It had very low salt content, which meant it had very poor buffering capacity. The pH dropped. Fast. And now we had small pools of acidic, stagnant water. Unmitigated. Unprotected. Why unprotected? Because even though the corrosion inhibitor was still being injected, and pigging was still done every 30 days. The inhibitor never arrived to the scene of the crime. Those stagnant pockets of condensed water weren't receiving corrosion protection between pig runs. They just sat a day. Growing more acidic. Attacking the pipe wall. And in 2025, it failed. Let's pause there. Because everything we just described. It happened despite following industry standard practice. 1. Continuous inhibitor. 2. Monthly pigging. 3. Zero deviation from the original mitigation program. The root cause wasn't operational negligence. It was static thinking. The mitigation plan never changed, even as the operating conditions did. Flow rate dropped by 95% over 20 years. Water behavior changed. Condensation zones appeared. And still, same program. This is where Quick Assess makes the difference. Quick Assess isn't just a model. It's a way of thinking. It simulates the over-life behavior of internal corrosion hazards based on terrain, flow rate, pressure, temperature, and fluid phase behavior. And it shows how and when a mitigation plan needs to adapt. With Quick Assess and a CMP-IC, we would have seen the hazard in 2020. We would have known that at 2 million standard cubic feet per day, inhibitor wouldn't reach the last mile. And we would have acted, maybe with an extended pigging interval. Injection of a volatile vapor phase corrosion inhibitor that travels with the gas, designed to elevate the pH of the stagnant condensed water traps. Maybe with slug MEG batches following each pigging run to create a MEG water mixture within regions of stagnant free water, or perhaps installation of dehydration unit at the upstream compressor station. But we would have acted. Instead, the pipeline failed. Because the mitigation plan didn't evolve. This is an example of how Quick Assess gives you a living roadmap. One that evolves with your asset, your budget, and your production profile. Because at the end of the day, this isn't about chasing leaks. It's about positioning mitigation to arrive before corrosion takes hold. Quick Assess and CMP-IC projects are the future of internal corrosion management. And the best part? This isn't some six-figure project. For $1,500, you get a risk-optimized, simulation-backed plan that tells your ops team what to do, why it matters, and what to watch for as things change. Visit trustedpipelineadvisor.com to learn more, or reach out to explore how quantitative internal corrosion assessment and risk-optimized corrosion management plans can become a valuable complement to your existing integrity management program. Imagine the benefits of investing only $1,500 to achieve insights never previously possible. Thank you for listening.